and like I said before, do you even need a vertical alignment? So if it's a simple resurfacing project, you're not going to have a vertical alignment. You'll just simply do a plan sheet where it's basically a plan sheet up here and a plan sheet down below. It just tells the contractor what happens at those different stations, whether you have guardrail or you're fixing a catch basin of some sort or something like that. All right, so after you have your horizontal vertical, and again, before you even do this part here, you would get that checked by the engineer. And you might even get it checked by the agency. All right, so it's usually because when you start to get into the modeling process or the typical section, where you do actual road, you want to have that kind of done. Now, the great thing about the software that we use nowadays, it's all dynamic modeling. And what that means is if you change any aspect of the horizontal and vertical, it just updates the model. So it's really, really nice. Whereas in the old days, about 20 years ago, 30 years ago, you did not have that functionality. If you changed the horizontal and vertical, you had to redo your model or redo your cross sections kind of by hand. And so it was kind of a pain. Whereas now it's really not a huge deal if it has to be changed. Okay. So once that's all approved, then you obviously already know your typical section. You'll have 12-foot lanes, paved or unpaved shoulders, and then your end conditions. Are you going to have a ditch? Are you going to have a fill slope, etc. Now, once that's done, you may revisit the right-of-way, because remember, the right-of-way was thought about beforehand, but that was just preliminary. That was just basically a conceptual modeling. It wasn't even really modeling. It was just more of just, hey, can this kind of road fit with these basic variables? Once you now actually have the road, you may actually have to revisit and actually redo your horizontal. So you might be going back to this stage here to take care of the stage where you may or may not have to be concerned with right-of-way. All right. And just to kind of show you that here, so this project here, this is basically what's called in a Civil 3D. That's the civil engineering software by Autodesk. This is an assembly. So your assembly is your actual road. And then all these components here are what's called sub-assemblies. Now, as you can see here, I had to add quite a few conditions because this project was kind of complicated. I had a berm in one spot. I had a pond in a few spots. I have special ditches that I have to follow. I also have guardrail, so I have to add guardrail, and I also have to add guardrail panels for the actual pavement, because in Florida they actually they put a pavement panel where the guardrail is to support it better. Okay, so it doesn't erode the guardrail out. All right, so you can see here you can have a really simple project, or you can get as complicated as is necessary. You're also going to have to think about intersection modeling, and so these are curb returns around the intersections. Okay, you're going to develop these assemblies, and the company you work for may already have some standard assemblies where you just basically plug and play, and you're just doing targeting where you say, okay, follow this horizontal alignment, follow this vertical alignment, follow this ditch profile, etc. Okay, here's the completed road, and as you can see, it's tying into the pond here, and we have some other locations. This is basically what's called the corridor model. This is also tying in here, tying in. Here's intersection modeling. All right, that's a whole kind of special workflow that you have to do. It's not hard. It's just a matter of understanding how the actual software works. Now, one of the things I'll just kind of show this to you is, let me go ahead and select my finished ground surface. So this is a surface that is the combination of all the proposed surfaces, the road, the ponds, and existing ground. I like to do this because it helps me kind of see the actual road in 3D, right? So you can kind of see my roads coming along here. You can actually see the ditches coming into the pond. The pond is going to outfall over here, or sorry, the road's going to outfall into the pond over here. Then we have some more ditches, another pond, and then this project basically just follows the existing road for the remainder. And so we don't have any ponds that go up here. But you can kind of see that to kind of fit the road, we're on existing, but we still are adding curves as needed. They're very large curves, so no super elevation is required. Okay, but again, this is kind of what you're going to be doing back and forth, and it's really crucial that you get into it. You'll kind of do that preliminary. Then you may have to go back to the horizontal vertical, change things there, and then basically you're going to do your fine-tune modeling. And that's what I was just kind of showing you there, was you're going to really have you're going to do drainage properly. Again, everything has to work. Basically the engineer always says, imagine one day they put a mall where you have, let's say, water that you didn't take care of. Whereas now, let's say it's dirt, it doesn't matter. But imagine 10 years they put a mall there or something like that. Well, you're gonna have to take care of that water that's flowing. You want to make sure that actually it flows correctly and flows into the spots that's naturally occurring. Or currently. And again, if you are realigning the road, you're going to have to put a pond. All that water that you're actually treating has to go into the pond. So these are things you're going to have to actually do. So you're going to do pond modeling, special dish profiles, and as you see there in italics, to be successful in this career, you really have to be a modeler. Things have been changing, but they're going to drastically change, in my opinion, in the next 5 to 10 years. Basically, everything that before what we currently have for software, etc., you would just submit plans, and plans are what is the final product for the actual construction. So the contractor who would get the project, they have to follow the plans. Well, that's changing. In Florida, in Michigan, in different agencies or in states or in countries around the world, they're requiring the engineer to sign the model. So the actual model itself, the CAD model itself, needs to be signed by the engineer. So that's something new. So that means your model has to be spot on. And that's why I say there, you have to be a modeler to succeed in this. That's how it's changing. In fact, within the next 5 to 10 years, we're probably not going to submit plans at all. You're going to submit the model, and that's it. That's, in fact, because in theory, that's all you actually need. And that's the thing too, is if you're working for an engineering firm, the majority of the time that you spend on developing quote unquote plans is actually developing the model, because the plans come from the model. So that's basically the change that's occurring. It's kind of exciting because it actually will save a lot of time. You spend a good amount of time doing plans as well, and if you don't have to do that and all you got to do is model, that's going to be great. You may be required to actually do some general plans where you have a big, humongous plan that shows your entire project for submitting for permitting and that type of stuff. But for the most part, the model is going to win with everything. Okay. All right. That said, unless you work for an agency that does that, you're going to have to get your plans together currently. Okay. What does that require? What does that entail? Plan and profile sheets. Only plan sheets for like a resurfacing project. Cross sections, pond sheets, etc. Okay. So as I kind of briefly showed you before, let's just start from the top here. So this is a full set of plans. You can see here it's 131 sheets. It's a 2.25 mile project. Okay. This is a cover sheet. It just shows the index of sheets. I'm not going to go over everything, but I'll just go over kind of the categories. All right. So then, of course, you're going to start having your project notes, anything specific to the project. Some are very generic. Usually this is a template, and then you just kind of edit it. Then you have your typical sections, where basically you tell the contractor, okay, what's the width of the lanes? What's your shoulder like? Do you have a ditch? What size is that ditch? So when someone says a 2-foot ditch, they're not talking about a 2-foot width. They're talking about a 2-foot depth, because that's the amount of water that it needs to hold, right? Because obviously during events, during major storms, you need to have the hydrology be able to carry it off the road into the ditch and into the waterway or the pond or wherever it's supposed to be going, okay? So whatever typical sections you happen to have for the project, you have to put them in there. So this is for a side road, and this is for a driveway. So because that driveway was kind of a little bit of a complicated design, I actually had to add a typical section for it. Usually you don't put it, driveways don't all get typical sections. This one's a pretty long one because it's near the pond where it's going off of the alignment. And then of course with this one, I was milling and paving, and we're tying into an existing road. And so we milled and paved that road. So you can see here it's a really basic typical section where it's just basically take out 2 inches, mill 1 inch, and then put back 1 inch. And then here is the actual plan and profile sheet. So again, a lot of this stuff is 2D, like this hatching is just done by 2D drafting. You're kind of offsetting alignment, putting in transitions as you need to, etc. Okay, the guardrail, that's not 3D. That's actually a line that's offset from the alignment, and basically it's just drawn in there. Okay. A lot of these other notes, though, these are all like 3D notes. So this stationing that you see here, begin project station 13077.6, that's coming from an alignment. So that's a 3D object. So if I move that label along the project, it'll update automatically. So it makes life a lot easier when you're doing kind of setting plans up. Again, these are all plan and profile sheets. These are actually, for the most part, coming from the model. Okay, that's kind of what I mean by if something updates, this all updates as well. So that's a nice thing. So you have plan and profile sheets, then you have cross-section sheets. Right, and there are a lot of cross-section sheets. Typically, you cut cross-sections every, I went a little too far there, every 100 feet, all right, that's what you're doing here, okay? And you also need to cut cross-sections at the critical points where your super elevation occurs. Basically, where super elevation begins, where the transition ends, where the transition begins, that type of stuff. The contractor needs to know that, all right? Then we have pond sheet. So here's my first pond. Basically, you have to tell the contractor, okay, this is my pond. This is the elevations of the pond. Where's your permanent pool? This is a wet pond. Okay, a wet pond actually has water in it. And it has basically, this is the seasonal high water table, right? Basically, it's down to where, no matter what, the water is just where that is. Okay, it's the groundwater. And so obviously your borings that you get by the boring engineer, or the geotechnical engineer, that is how you decipher what your permanent pool or your seasonal high water table is. There are also dry ponds. The dry pond would be above the seasonal high water table. Dry ponds are a lot harder because they actually require that you have enough percolation in the soil to actually let the water drain. Whereas this one here, it outfalls to a structure, as you can see right here. This is where the outfall structure is, and then the pond just stays wet, so it's not a big deal, right? And some other ponds, notes for those ponds, and then we have erosion control plans, and then you have a project control sheet, right? How does the contractor know how to do this in the field? So we give them northing, easting, and elevations, and where these are located along the alignment. They need to know that. And in this case, this project actually had a detour plan because we were closing the bridge, and so this is a detour plan. But not every project will have a detour plan sheet, okay? So again, that's kind of getting your plans together, okay? That's what you're gonna do. And that will require some amount of time. Now again, this is changing. This will actually, this may or may not be a thing of the future. Like I said, I think within the next 5 to 10 years, you're not gonna have a full set of plans. It's gonna be just basically some basic plans that show the general design of the project. It'll be a really big PDF basically, all right? So once your plans are, once you've done your plans, okay, there obviously needs to be checked by the lead engineer, unless you're the lead engineer. Which hopefully that's your goal someday. So the lead engineer will check the plans, and every engineer is different. We still have a generation now, and nothing wrong with this at all. We still have a generation now that does like to, they're an older generation, I would say, and they want to have plans printed. It's that simple. I myself, I'm 48. I actually like my plans printed too. It's just, for me, it's easier to actually just, go through the plans and look at them and draw on them and et cetera, okay? I do all that time marking stuff up on or doing stuff in the computer. I like to actually have a set of plans that I can look at. But that's changing too. I like Bluebeam. Adobe does this as well. But Bluebeam is a really nice tool. It's also a lot cheaper than Adobe. And you can actually do markups right here. And this is the kind of stuff that you'll see. They may come in and say, okay, well, this right here is the wrong size. So they'll just come in and just, basically, type in wrong size here. And so now I've got this markup here. And what's nice about if this is done electronically, what's nice is as you have the markup, it actually brings it up here. So you can click on it and you can know where it is. Then what you can do is right click here and you can say, okay, I'm going to set this as completed. And now it's done. And then you save this file. So this is a PDF. It's not affecting the design at all. It's just basically a way for you to mark it up. Some engineers actually like using this. It takes, in my opinion, it takes a little bit more time, but what's nice about it is it's an electronic copy of everything that's done. And so you just basically do this, you save your PDF, and then, when the lead engineer saves their markups, it then will tell you, hey, I finished my markups. You can actually go in there and now, I need you to complete them and get me a new, and then you get me a new set of plans, right? And basically the fact that you have these markups right here, you can just click on them and navigate to them very easily. And then in CAD, you would go in and actually, complete the markups, and then you'd reprint the plans. All right, once that's done, you're going to actually do your quantities, okay? And basically what you want to do is you want to get what's called the final estimate, right? Before we did a preliminary estimate to get a budget, right? That was just to get a preliminary. And again, it should have enough fluff in there so that you have a good amount of money that's possible for things that you may have missed. So here, because obviously now the project is done in CAD, you can get areas, lengths, volumes, everything from CAD. That's the whole point. That's the reason we do this. So the model is already basically providing for you, and the 2D graphics will provide for you, whether it's square meters, cubic meters, cubic yards, whatever you're working in, you'll get your areas and lengths and so on from there. Then you'll put that into a final estimate, and you'll basically compare the budget that you did initially to this one. If you're over, well, you hope that the contractor bids low. But again, if you're over, it gives you an idea at least, okay, we may have a possibility. Here's the thing too, is if you're over by too much, you may be able to go back and say, okay, let's change some things in the design now. Again, because everything's kind of 2D or 3, it's all related, you can pretty much change your design, and actually it'll update the plans kind of automatically. All right, so before it gets completed, or you can put it out to bid, you're going to submit the project to local agencies for review. You're also, again, if you have ponds, and even if you don't have ponds, if you're just reconstructing a road, you're going to or if you just, but it's staying on existing, you're going to have to submit to water management as well, because they will provide what's called, usually, again, every state, every country is different, but they'll have like a permitting, you'll get a standard permit where if you're on existing road, it just, in Florida, it's called dusty roads. I don't know what's called in every country or state, but basically it says, okay, you're already on existing, you're not extending culverts or anything like that, or changing the waterways or changing the way that it's draining now, you should be good to go because it's working now as it is, and there's no complaints, there's no issues with water quality and that type of stuff. Okay. And of course, the local agencies might be a municipality, might be the county, might be the ministry, etc. And they need to review the project as well. All right, so of course that will usually take about 30 to 60 days, depends on the project, depends on their project load, etc. And what they'll do, usually, again, most agencies are pretty electronically savvy at this point. This is all going to be done by email, or it's going to be all done by like an interface on their website. Typically, like I said, every agency is different. They'll basically say, okay, page 1, you need to change this, and it's on this sheet, etc. And they'll give you usually a description, and so you'll have to obviously respond to their comments. Now, what may occur, the engineer might say, no, I want it done this way. I think I'm right. And so it may require that you guys meet in person to kind of, discuss the issue and actually then agree upon something. And again, in the end, the agency who's providing the money for the project usually will win. But every engineer, every agency is different, and may be able to come to some agreement where you compromise, or they say, yeah, that's fine. I see where you're going with this, because again, they're just seeing the plan. They don't necessarily know exactly what you had in mind when you did a specific design aspect or whatever. And then of course, once that's done, then you resubmit with the markups or with the notes saying was discussed at this meeting, etc. Okay, obviously you want to have a nice record copy of all that. So typically once that's done, then you are basically, given the project approval. Again, every kind of agency, municipality is kind of different. For most of the projects that I work on, usually they're state funded for the counties in Florida. And so typically we will then request through the state, hey, you've looked at the plans. Do we have request permission to advertise? Okay. Because we're engineers for the counties. And so what we will then do is once we get that permission to advertise, we will tell the counties, okay, it's ready to be put out to bid. And so what is that bidding process? Okay, so again, the bidding process requires a few things. But what you're going to have to actually do, you're going to have to figure out construction time, because you need to tell the contractor what you believe the contract time is. You don't want them, spending too much time on a project, but you also want to make sure that you give them enough time to actually build that project. Now, there are many spreadsheets out there that and usually the agency will actually have its own spreadsheet, and they basically have a state average that they will know for specific quantity. And what that means is basically, if let's say they're doing pavement, they say, okay, to do 100 tons of pavement, how long does that take per day? And so that they get a rate. And so that rate is then how much per day, how much it's going to take. Now, here's the thing that you also can be aware of. Usually during construction, they're not just doing one thing. It's not a linear process. While they're laying out all the drainage structures and all the pipes, they're going to be doing clearing and grubbing, they would do clearing and grubbing first, but they might be doing the road. So they might be doing stabilization of the road bed. Then they might be doing optional base group or the lime rocker that's underneath the road, or sub base that's underneath the road. And then they might be doing different aspects like ponds and so on. So all of that can be going on at the same time. So the ones that can be done during the same time, that you would include those in the same day that they might be doing other things. It takes a little bit of experience doing that, but that's something you have to come up with. The other thing too that you're going to include, you're not going to include the price, because you don't want the contractor to know how much is bid, how much is actually being done. So typically what I'll do is in my estimate, I'll have what's called a bid form. Here's my bid form, and you'll see here, this is completely blank. So the unit price and the total cost are blank. It's up to the contractor to fill this out. But the contractor, because they can't, of course, know the quantities for this project, this is why you are developing this has to be as accurate as you possibly can get it, because this is what the contractor is using to get the estimate for the project. They're going to provide their own unit price and which of course is just basically this times this, right? And then it's going to be a total cost. However, if you look here, here's my estimate, and this is based upon the prices that we've had throughout this area of the project, etc. And so for this project, I expect a bid to be no more than 1.2. I usually will put some fluff. Now again, I have compared this to my other one. It turns out my original estimate for this project was about 1.3. So we were actually pretty good. but the contractor came back actually, and they were actually a little high. And so that was okay. So there was this additional money and that was needed. So from there, you may need to actually then either go back to the agency and say, hey, we need $100,000, we need $50,000, or if it's a local government and they have enough in their coffers, then they may actually fund the rest of the project. All right, so again, it goes out to bid. Usually you have to provide at least a minimum of 30 days for it to go out to bid. And again, but what happens is the contractor actually is usually a member of some sort of bidding warehouse, and they pay a subscription for that. And what the warehouse will do is it actually will notify them, okay, hey, you basically pick an area that you want to get notified from, and they will then notify the contractors and say, okay, hey, there are 3 projects in your area that are out to bid. And then it's up to them if they want to bid on that project. Obviously, the more bidders, the better, because competition is good, because it gives you a lower price. If there's only one contractor, usually they know it. They may or may not know it. It depends. Sometimes there are ways for them to find out. It's usually it can be public knowledge. Sometimes if they submit comments, then they know that other people are bidding on the project. If they know they're the only ones, they're going to bid high because they know that they'll be the only ones. Can it be put out to bid again? It can. Usually the county or the agency can say, we always reserve the right to put it out to bid again. All right, so once bids are received and they're approved by the county or the agency, low bid will usually win, okay? So for this project here, we had 2 contractors, which was good. It brought the price down a little bit. But what I also will do is I'll do a price comparison, like for this one here, because it came in at $1.4 million, and we only had 1.2. I wanted to make sure that the contractor wasn't gouging some prices in some sort of way, because they have done that. So you just use Excel, and as you can see here, I've got their unit price, the cost, the difference, and then I can kind of see, okay, well, which one, I usually have a graph, I'm not showing it in this one, that will highlight the one that was really expensive, showing a large majority, a large discrepancy in like the state average unit price. Once that's done, then you have project construction, okay? And so, again, in the old days, many years ago, you would just give the contractor your plans and that was it. You were kind of done. This is changing completely, okay? And it's been changing for a while. There's a term you want to be aware of. Again, in every country, it's probably a little different, but it's typically called AMG, Automatic Machine Guidance. And what it does is, as you can see by that little image there, is it uses GPS, and all the different construction vehicles will have actual GPS units on them, and the model will be loaded into the graders and bulldozers, etc., and they literally let the machine do its thing. It's just hands off. It's actually pretty cool. I've seen one done. I've driven one, and it basically just it's really a great thing. So what the contractor will usually require, they want DWG files usually. Okay, that's Autodesk. All right. Bentley is another software company that does. They're very popular in the roadway agencies and stuff. However, in the end, the contractor is the one who is doing it, and they may have a license of Bentley, but typically they have AutoCAD and they want DWG. And their graders will basically allow them to bring in what's called a DXF file, which is a different exchange format, but it's DWG based. So basically, that's why they want that. They also may ask for LanXML from you. LanXML is a non-proprietary format, and basically it's a way to export your model to this. It's almost like a text file, but all civil engineering software out there, including the software in the graders, can read LanXML. And that LanXML file is then used as the model, okay? So that's another thing. Now, some of the things that may arise depends on what your job is in the realm of as a consultant. If issues arise, usually a note in the plan says, any issues that arise, please contact the engineer. You must contact the engineer before even beginning to do construction. So they may contact you, and then you'll have to address these issues. And sometimes it'll require a change order, which means more money. There are projects I've worked on where an elevation was messed up on a catch basin, and we had to pay for a whole new set of catch basins because it affected the drainage for the entire project. So issues can arise, but that's why you do checks and everything like that. Contractor may contact you for other things as well.